Saxon Algebra 2, lesson 31. We're talking about perpendicular lines today. I'll remind you what perpendicular lines are in just a minute, but first I want to introduce another idea. Negative reciprocals. Now, you probably remember what a reciprocal is. We've talked about those quite a bit. That's when you take a number in a fraction form and you flip it over, right? You put the bottom on the top and the top on the bottom. And the cool thing about negative reciprocal, or reciprocals rather, not negative reciprocals. The cool thing about reciprocals is that when you multiply them together, they always equal 1. Negative reciprocals are just a tiny bit different. Let's say we have the reciprocal of positive 2 over 5. The negative reciprocal is negative 5 over 2. So the sign changes as well as the numbers flip, all right? And negatives turn to positives, right? So negative reciprocals just means that you change the sign as well as flip the numbers. Okay, before we talk about perpendicular lines, let me just remind you about parallel lines because it's easy to get confused between the two. I'm gonna play graph them. Parallel lines would look something like this, right? They never touch. They say the same distance apart from here to forever. And so from the point of view of the equation of a line, parallel lines always have the same slope. And remember, we measure that in a number we call m, right? In y equals mx plus b. Okay, now we're gonna compare that to perpendicular lines. Perpendicular lines form right angles to each other. So if we have our Cartesian coordinate system, they would do something more like this and this. I'll put arrowheads on it so you can tell which ones are the graph and which ones are the actual line. They meet at a right angle, okay? When you have perpendicular lines, the two slopes of the lines that meet at a right angle, they are negative reciprocals of one another. Okay. That's why I talked about what negative reciprocals are up here, is because I was going to tell you down here that that's how you find, if you're told the slope of one line, and then say, hey, that line is actually perpendicular to another line, then it's a very easy thing to find the slope of the other line. All right? The problem, and it's not a big problem, it's a small problem, is that we get confused with parallel lines. Parallel lines have the very same slope. And if you look at the picture, that should jumpstart your memory when you're trying to keep these straight, because look, they look exactly the same. Oh, excuse me. It would make sense that these guys have the exact same slope. These do not look like they have the same slope. It makes sense to say, oh, their slopes must be opposites in some way. So we'll work on keeping these two straight. All right, let's try some problems. Won't that be fun? I'm excited. How many problems are there? It always helps me to know. There's really just one. Example 31.1. It says, write the equation of the line. As soon as I see that much, my brain goes, oh, equation of a line. I've got that. Write the equation of a line that is perpendicular to y equals 2/5 x minus 3. Okay, here's what I like to do. I like to make the little sign of perpendicular instead of writing it out because it has too many letters. This line that we have is perpendicular to y equals 2/5 x minus 3. Okay, remember that perpendicular? I'm just going to write this again just so we know. Perpendicular is a fancy word that means they meet at 90 degrees. And a way that we can draw that is to draw the angle and put the right angle marker in there. And remember that right angles are always equal to 90 degrees. Okay? So all those things are the same. Okay, and this line that we're talking about, it also passes through a point. That John tells us, and it is 3, 2. And John wants us to find the equation to our line, okay? This is some other line. Our line is perpendicular to that line. Our line passes through that point. So the first step is to find the slope of the other line, right? There's our line and then there's this other line that we're using. Well, John was very nice and gave this to us straight. Sometimes we have to rearrange things in order to get it into the proper format, but John was nice this time, and we can see that m equals 2/5. Okay, now the second step is to find the slope of what I call our line, the one that we're trying to come up with. Well, they're perpendicular, so we know that RM equals minus 5/2. It's the negative reciprocal. That was easy enough, right? And so our final step, we use our m and the points okay, we're going to use our slope and the points that were given. We're going to plug them into y equals mx plus b, and that will allow us to solve for b. Okay, so we need this. And we need these. This is x, this is y. So, using this formula, we'll say that 2 equals m minus 5/2 times x, which is 3, plus b. Okay, so we know, let's see, we're going to have to move this over here, and then we'll be good. This equals, I'm going to rewrite it, I'm going to multiply that out. It's minus 15/2, right? Minus 5 times 3 is minus 15, and there's the 2. So we're going to have to add 15/2 to both sides to solve this. All of that will cancel. We'll have our b by itself. Now, in order to do this, we're going to have to turn this into a fraction with a denominator of 2. So we'll multiply it by 2/2, right? And this will equal 4/2. Now we can add these together and we'll get, I'll write it over here, b equals 4 plus 15 is 19/2. All right, so now we're ready to write the equation of our line. Oh, I don't have room, but I don't want to move to another page. I'll write it here. I'll just squeeze it in. So our final answer is we're writing the equation of the line in that format. Y equals minus 5/2x plus 19/2. And that is a crazy looking line. I wouldn't want to have to graph it, but we don't have to. Those are the right numbers. Okay? Whew, beautiful. All right, so that's the secret of perpendicular lines. Remember that perpendicular means they meet at a 90-degree angle. And we can use the picture of a right angle to indicate that lines are perpendicular. And then this is how we can use the slope of the other line by taking the negative reciprocal. And that will be the slope of our line. Now, there's one more problem in this lesson, and it relates to proofs and geometry. I really want to say, with all the sincerity that I can, please don't worry about proofs this year. Let me just show you a few things. We'll talk about them, but I don't want you to worry about them. I just want you to let them float into the back of your mind. Next year, when I call them forward, you'll say, oh yeah, I kind of remember that. It makes a lot more sense this year, which is what everyone says, right? And it's gonna be much, much, much better if I just plant these ideas ever so gently in your brain. So what we're looking at right now is a simple idea. We've got a triangle. It's got 3 angles in it, and we know that they add up to 180, right? We also can draw this line out and call this an angle D, right? Just a second. We know that A plus B plus C equals 180, right? And we see that angle C plus angle D equals 180 because they form a straight line, right? What John asks us to prove is that angle D is what we say congruent to, the same size as angle A plus angle B. Now, how can we possibly prove that these two equal the total of that? Do they even? We don't know, but we can prove it. We've started down the path. We've started down the path by writing what we already know. These 3 add up to 180. There's another proof that proves that. We skipped over that, but you can trust me, that's true. And we know that C and D are supplemental, right? They form a straight line, so they equal 180 as well. If both of these things equal 180, then we can put them equal to each other. We can say that A plus B plus C, which equal 180, have to equal C plus D, which also equal 180, right? So we took these two and we stuck them together. And now we're gonna subtract C from both sides, because we can subtract the same thing from both sides. That won't hurt anything. And now we get angle A plus angle B equals angle D, which is exactly what John asked us to prove way back in the beginning. So we did it. We proved it through this little exercise. And what John likes us to write, although next year we're not going to do it that much, at the end, we write the letters QED, which are Latin, and it means that which was to have been demonstrated. So which is another way of saying, if this is saying prove this, this is a way of saying proven. Gotcha, showed ya. Okay, so this is kind of a fancy flourish that goes at the end of proofs. What I want you to take away from this is that the idea behind proofs, the ideas behind proofs are usually quite straightforward, right? There's a little trick in understanding how to set them up, but it's just following logic to prove what you've been asked to prove. If this makes any sense to you at all, congratulations. That's all you need to do. I do not believe John gives us any homework problems in this. And let me know if he does. because I don't want you to do any proofs until next year. All right, I just want you to look at them and follow along as I explain them and go, yeah, okay, that sounds good. Sounds good. Moving on. That's all you need to do. Okay, that's the end of lesson 31. Thank you. Goodbye.